Previous neuroimaging studies have identified several left lateralized frontotemporal regions that are involved in syntactic processing. These regions include Broca's area, the posterior temporal area, and the posterior middle temporal gyrus, among others, collectively forming the syntax network. Using resting state functional magnetic resonance imaging to identify brain areas with statistically significant rates of coincident activity, you et al. 2022 investigated how the syntax network works collaboratively to facilitate syntactic processing. Furthermore, you et al. Sought to determine the behavioral relevance of this network by correlating the interconnectivity of different regions with an individual's performance on a test assaying syntactic comprehension. Researchers hypothesized that the left posterior middle temporal gyrus would serve as a hub that integrates syntactic information from other regions within the network, given that previous studies have identified that it is highly correlated with many left frontotemporal regions in the syntax network.
The study examined the syntactic processing ability of 180 healthy college students from Beijing Normal University. Participants completed syntactic and word-level language tests outside the MRI machine. The syntactic tests used Chinese sentences with two relative clauses, structured canonically or non-canonically, and included a plausibility rating task to control for potential differences between conditions. Participants completed a 60-trial sentence comprehension task with 2 yes-no questions per trial, taking a short break every 20 trials. Trials began with a 0.5-second fixation followed by a sentence and a first question. A 4-trial practice session preceded the formal test. The study assessed participants' syntax processing ability by comparing subject-extracted RC to object-extracted RC. Word-level semantic and phonological processing abilities were assessed as control variables using animal word and onset cancellation tests, respectively. fMRI images were acquired and motion and noise were reduced. Resting state functional images were pre-processed with feet and registered to MNI space with FLIRT. NeuroSynth defined the syntax network, and the GBC method analyzed voxel integration in the network. WNC maps were transformed with Fisher-Z transformations. The study investigated the correlation between white matter connectivity and syntactic processing. They found a significant association between a cluster's connectivity and syntactic scores controlling for head motion and semantic/phonological scores. They also explored which regions had functional connectivity with the identified region.
As expected, all participants performed well on the sentence comprehension task, with lower accuracy and higher reaction time reported in syntactically more complex conditions relative to the syntactically simpler conditions. Next, and after defining the syntax network based on previous meta-analyses, the authors calculated within-network connectivity for each voxel in the syntax network. All voxels within this network exhibited statistically significant within-network correlation scores, indicating that these are all part of a functional neural network. Third, a global brain connectivity analysis, which sought to correlate within-network connectivity of each region in the syntax network with individual syntactic ability as assessed through the behavioral test, revealed that the left posterior middle temporal gyrus was significantly and positively correlated to participants' syntactic processing ability. This suggests that the left posterior middle temporal gyrus plays a hub-like role in the brain's syntax network.
In the study, LPMTG was identified as a hub for syntactic processing, positively correlated with individual syntactic ability. The proposed neural model of syntax involves LPMTG interacting with Broca's area and AG for semantic mapping. LPMTG plays a central role in hierarchical syntactic processing. The study also found that the FC between MFG and LPMTG contributes to syntactic processing, potentially reflecting differences in working memory capacity. Additionally, the study found behaviorally related FCs with LPMTG that were independent of the task, suggesting maintaining meaningful inherent interactions for better syntactic performance during the resting state. The study identified LPMTG as a neural hub for syntactic processing, but limitations and unaddressed issues require further research. For example, task-based fMRI is needed to examine functional integration during syntactic tasks, and other syntactic tasks should be explored to understand the role of the FCs. In addition, defining the SN individually and investigating its connectivity pattern with behavioral performance is needed. Finally, future research is needed to investigate the global connectivity pattern underlying syntactic production.